Good day, grade 4 pupils. Welcome to our Valenzuela Live Mathematics 4, where you can learn and enjoy math. I am Sir Victorino Bernales from Andres Fernando Elementary School. Recognize your participation in our today's live session. Please comment down your name, grade and section, name of your school, and the name of your mathematics teacher. If you like to answer during the discussion, you may also type in your answer in the comment box. Learners, be ready to be introduced to these mathematical terms, such as factors, multiples, prime numbers, and composite numbers. So we are now on our second quarter, week 1 of our most essential learning competence. For today's lesson, you have to master the following skills. First, you have to identify the factors of a given number up to 100. Identify the multiples of a given number up to 100. And lastly, you have to differentiate prime numbers from composite numbers. Let us first define these mathematical terms in mathematics. First, we have factors. Factors are the numbers that are being multiplied to get the product. Factor is a number that divides another number without leaving any remainder. Multiple. Multiple is the product result of one number multiplied by another number. It is obtained by multiplication process. Prime number. A prime number is a number with only two factors. One and the number itself. Composite number. A composite number is a number with more than two factors. Okay, so before we start with today's lesson, let us first help Jean Fritz find his way home by doing this activity. Identify the missing number in the given equation. Every time we choose the correct answer, the road will be unblocked. Let us start with the first one. 100 times blank is equal to 50,000. Is it 500 or 5,000? So the correct answer is 500. Next, blank times 10 is equal to 250. Definitely, the answer is 25. Next, 4,500 divide 10 is equal to blank. Is it 45 or 450? The correct answer is 450. Next, 6,524 divide 100 is equal to blank. Is it 65 remainder 24 or 652 remainder 4? Correct. The answer is 65 remainder 24. Next, 48 times 100 is equal to blank. Okay? The correct answer is 4,800. And for the last one, we have blank divide 100 is equal to 34, remainder 20. Which one do you think is the answer? Correct. It's 3,420. Good job! Upon reaching home, John Fritz counted the marbles he collected. After counting, he thought of doing something with these marbles. I have 20 pieces of marbles, and I want to group these marbles in different ways such that no marbles will be left behind. How do I do it? In what way can we help Sean Fritz? Let us try to do some illustration. So we have here 20 marbles. Let us group these marbles by 2. Okay, and now we have 10 groups of 2. And we know that 2 times 10 is equal to 20. And so, we are now sure that no marbles are left behind. Then let us group the marbles by 3s. How many group of 3 we make? What have you noticed? Yes, there are 2 remaining marbles. And when we multiply 3 and 6, we only get 18. Therefore, 2 marbles are left behind. So now, let us group the marbles by 4s. How many can we make? You see any remaining marbles? We are able to make 5 groups of 4. And when we multiply 4 and 5, the product is 20. And so, no marbles are left behind. Let us now group the marbles by 5 at this time. So as you can see, we are able to make 4 groups. Thus, 5 multiplied by 4 is also equal to 20. What other way can you think we can group these marbles without any remainder? Yes, that is correct. Grouping by 10s will give us 2 groups. Thus, 10 multiplied by 2 is equal to 20. Let us combine all the marbles again. And so, we have one group of 20 in which 20 multiplied by 1 is also equal to 20. Now look at the table that we made. Even though we multiply different numbers, we are able to get the same product, which is 20. These numbers that are multiplied together are called factors of 20. To list down the factors of 20, from smallest to biggest, we have 1. And so with 2, we also have 4. Okay, so we also have 5. And lastly, we have 20. Let us now have other examples of finding the factors of a number, but we are not going to illustrate this time. Instead, we will use the division process. Our number is 36. Okay? So, identifying the pair of factors, you can always begin with 1 because 1 is always a factor of every number. Thus, 36 divide 1 is equal to 36. So, the first pair of factor is 1 times 36 is also equal to 36. Now, let us divide 36 by 3. And that is equal to 8. 36 by 2. That is equal to 18. Therefore, 2 times 18 is also equal to 36. Next, let us divide 36 by 3. Okay, so the answer is 12. Then we have 3 multiplied by 12 is also equal to 36. For the next pair, you have to divide 36 by 4. Okay, the answer is 9. Therefore, 4 times 9 is also equal to 36. Now, we try to divide 36 by 5. And the answer is 7, remainder 1. If there is a remainder, then 5 and 7 are not factors of 36. Now, let's try to divide 36 by 6. The answer is 6. And so we have 6 multiplied by 6 is also equal to 36. Divide 36 by 7. We can see remainder. Okay. The next number that we can use to divide 36 is 9. But since we already have 4 times 9 in our pair of factors, then we can already stop the division process. We can now identify the factors of 36. Thus, we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Are you ready for our first activity? That's great. For our first activity, you are going to list down all the pairs of factors of 30 that you can find inside this box. Type in your answers in the comment box. You are given 30 seconds to finish the task. Are you ready? Your timer starts now. Okay, so you have 20 seconds left. 10 seconds left. 5 seconds. Okay, time's up. Let us now check your work. So the pair of factors for 30 are 1 times 30 equal to 30. And then we have 2 times 15 is also equal to 30. We also have 3 times 10 is equal to 30. And 5 multiplied by 6 is also equal to 30. Great job! And now, let us try it with 24 this time. Again, you may type in your answer in the comment box. You are again given 30 seconds, and your timer starts now. Okay, you have 20 seconds left. 10 seconds. 5 seconds. Okay, time's up. So now, let us check your work. At this time, we have 1 times 24 is equal to 24. 2 times 12 is also equal to 24. And then we have 3 times 8, which is also equal to 24. Lastly, we also have 4 times 6, which is also equal to 24. Good job, grade 4 pupils. Let us have a second look at the pairs of factors of 24. We call these numbers as factors. What do we call on 24? "24" is also known as the product. And we can also call it as multiple. As mentioned earlier, a multiple is the product result of one number multiplied by another number. So, if we want to find the multiples of 4, we can do it by multiplying 4 with another number, such as 4 times 0, which is 0. Okay, so 0 is the smallest multiple that we have. Then we have 4, 8, 12, 16, 20, 24, 28, and 32, and so on. Let us try it with 3 this time. Tab 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So what we have observed, what did they do to get the multiples of a given number? If we set aside 0. Correct. What I did is the so-called keep counting. And so, if I want to give the multiples of 8, then we have 8, 16, 24, and 32. And so on. For 12, we also have 0, 12, 24, 36, 48, and many more. As you can see, 4, 3, 8, and 12 have 24 as their common multiples because they are all factors of 24. You also need to take note that multiples are infinite or never ending. Okay? So which means these 3 dots symbolize the infinity or multiple. You also need to remember that 0 is a multiple of any number. Also, a number is always a multiple of itself. Given this illustration, we have 4, 3, 6, 4, 3, 8, and 12. Let us have more examples of giving multiples of a given number with the given conditions. First, we give all the multiples of 3 that are greater than 1 but less than 25. So we have 3, 6, 9, 12, 15, 18, 21, and 24. We are not going to put the 3 dots after the list because all multiples greater than 24 should not be listed to satisfy the given condition. Next, let us give all the multiples of 6 that are greater than 10 but less than 40. We cannot start with 6 because it is not greater than 10. The first multiple of 6 is 12, followed by 18, 24, 30, and 36. Because of the given condition, that is less than 40. Great job, kids! Now, to practice what you have learned today about factors and multiples, I want you to participate in this next activity. For our next activity, you are going to type F if the number inside the heart is a factor, then M if it is a multiple, and N if neither a factor nor a multiple. Type in your answer as fast as you can. Are you ready? Let's begin. So our number is 50. Is 10 a factor, a multiple, or neither? Okay, the correct answer is F, because 10 is a factor of 50. Next, we have number 12. Is 12 a factor, a multiple, or neither? The answer is and. Next, we have 100. Is it a factor, a multiple, or neither? Very good. The correct answer is multiple. Next, we have 5. Is 5 a factor of 50, a multiple, or neither? Correct. The answer is F. That is a factor. Next, is 25 a factor, a multiple, or neither? Correct. The answer is F, because that is a factor of 50. Now, let us have another one. Again, you may type in F if it is a factor, M if it is a multiple, and N if it's neither a factor nor a multiple. Let us begin with 18. Now, we have number 6. Is 6 a factor, a multiple, or neither? What is the answer? Correct. That is a factor of 18. Next, we have 18. Okay, very good. 18 is a factor and a multiple of the number itself. What about 9? Okay, is 9 a factor, a multiple, or neither? Great. The answer is a factor. How about 12? Is it a factor, a multiple, or neither? Very good. The answer is N. Neither a factor nor a multiple. Next, we have 36. 36, a factor, a multiple, or neither? Great job. That is a multiple. Congratulations. You did great. Now, I want you to look at the chart having the numbers 1 up to 100. We are going to apply what we have learned about multiples. First, let us try to cross out all the multiples of 2 except the number itself. Okay, so we begin with 4, 6, 8, 10, 12, 14, 16, 18, and 20. And the rest of the multiples of 100. Okay, so we have also cross out the remaining multiples of 3 except 3 itself. So we have, okay, so the numbers 9, 15, 27, and so on. So we are done with the multiples of 3. Next, let us cross out the remaining multiples of 5 except to the number itself, which is 5. So we have, okay, 5, 35, 55, okay, then 65, 85, and as well as 95. Now, let us try to cross out the remaining multiples of 7 except the number itself, which is 7. We have 9, 77, and 91. Okay, so the remaining numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, okay? Then, as well as 73, 71, 73, okay? 79, 3, 89, and 97 are what we call prime numbers. And all the numbers that we cross out are called composite numbers. How about 1? 1 is known as the special number. It is neither a prime number nor a composite number. 1 is also a factor of all the numbers, and its only factor is itself. Now, let us differentiate prime numbers from composite numbers. First, in prime numbers, okay, the factors are only 1 and the number itself. For example, we have 19. 1 multiplied by 19, the factors is 1 and 19. While in composite numbers, are numbers with more than 2 factors. Example, we have 28. The factors of 28 are 1, 2, 4, 7, 14, and 28. Next, prime numbers are all odd numbers except 2, which is the only even prime numbers. Okay, examples of odd numbers, we have 17, 31, 53, and 97, and many more. While composite numbers can be even numbers or odd numbers like 8 is even number. Then we also have 15 odd numbers and 70 and 49 and many more. Next, prime numbers are divisible by 1 and itself only. Example, we have 23. And 23 can only be divided by 1 or the number itself. While composite number is divisible by all of its factors. Example, we have 21. So 21 can be divided by 1, by itself, can be divided by 3, by 7, and by 21. To sum up our lesson for today, I want you to provide the missing item in each sentence. For number 1, the blank of a number are the numbers multiplied together to get the given number. What do you think is it? Okay, great. The answer is factors. For number 2, the blank of a number, also known as products of the given number multiplied to other whole number. The answer is multiple. Okay, so next, blank numbers have only 2 factors, 1 and itself. We call them, very good, prime numbers. Next, blank numbers have more than 2 factors. What is it? Okay, we call it composite numbers. And for the last one, we have number blank is the only even prime number. The answer is correct. The answer is 2. Okay? Should remember, class, that every number has infinite multiples. All prime numbers are odd numbers except 2. 1 is a special number. It is neither prime nor composite. A number is always a factor and a multiple of itself. Let us now move on with the question and answer. Okay? Because that's the end of our discussion. So it's time for me to entertain your questions or clarifications about the topic that I discussed. Just type it to our comment box. For the first question, let me see. Okay, so the first question, are all prime numbers less than 100? Okay, the answer, there are prime numbers greater than 100. like 101 and also 173 and many more. These are the numbers that can be divided only by 1 and of course by the number itself. Okay, so let me see if there is another question. Okay, why is it all even numbers are composite numbers? Okay, so even numbers are divisible by 2. Only number 2 is the even number that are prime numbers. Okay, so according to Carl Sander, arithmetic. Arithmetic is a number you squeeze from your heart, your hand, your pencil, your paper till you get answer. That's all for today. Again, this is Sir Vic Bernales saying thank you, God bless you, and stay safe. See you on to the next Epi Live session. Bye, everyone!